Today, we're going to talk about how to solve exponential equations, equations with a variable in the exponent. We're going to start out with some easy problems by solving equations with same base. Let's start out with an easy term, for instance, 3 to the x power. Now, we're going to set that equal to a number, let's say 27. Now we know that if we take the cube root of 27, we get 3. So, we can also replace 27 with 3 to the third power, since both of these numbers are equal. Looking at both sides of the equation, we can see that each has a base of 3. Because both sides have the same base, we can set their exponents equal to each other in a new equation. In this case, x equals 3. Here, we already have our answer, so we don't have to solve any further. Now let's try another problem. This time we'll start with 5 to the 3x power, and we'll set that equal to the number 125. Just like last time, we can break this number down. In this case, 125 is equal to 5 to the third power. Again, they both have the same base, so the exponents on each side can be set equal to each other. Now, if we set 3x equal to 3, then divide each side by 3, we get our answer. X equals 1. Once again, very easy to solve. Now let's try some harder problems. Now we're going to solve more complex problems using the same base principle. This time, our equation will be 4 to the power 2x squared plus 2x equals 8. If you look, you'll see that the 4 can be broken down into the number 2 squared. In this case, the 2 in the exponent can be multiplied by the exponent of 4. Looking at the 8, we can also break this down. 8 equals 2 to the third power. If we set the two exponents equal to each other, we can multiply out the first side of the equation, 4x squared plus 4x. Then we pull the 3 from the other side, and now we have a quadratic function equal to 0. For this problem, we're going to factor down to 2x minus 1 times 2x plus 3. We can set each of these functions equal to 0, as we've shown here. The first side shows that 2x is equal to 1, which means that x is equal to 1/2. On the other side, 2x is equal to negative 3, which means that x is also equal to negative 3/2. Now, here's a tricky one. We have 4 to the power x plus 1, which is equal to the fraction 1 over 64. We can move 64 into the top of the equation, the numerator, and show that it's 64 to the negative 1 power. We can take 64 and break it down into 4 to the third power, then multiply the two exponents, giving us 4 to the negative third power. We can now use the equation x plus 1 equals negative 3. All we have to do is subtract 1 from each side, and we get our answer of x equals negative 4. The last way we can solve exponential functions is using the natural logarithm, also called natural log, or ln. We're going to use natural log when we have two terms that don't have the same base in an exponential equation. For instance, here's the equation 2 to the x power equals 30. There's no way that we can get these two terms to have the same base. So, we'll take the natural log of each side. Now our focus with these problems will be the term that has x in the exponent. In calculus, a rule states that when the natural log of a function is taken, it is equal to the natural log of the base times the value of the exponent. This means that the natural log of 2 to the x power is equal to x times the natural log of 2. All we have to do is divide each side of the function by the natural log of 2. This gives us the function x equals the natural log of 30 divided by the natural log of 2. We can solve this further and get an estimation of what this equals, but in most situations your answer will be more exact, which is the natural logs. Now let's try to solve the equation 10 to the 2x power equals 52. No same base, so we use natural log. This means that 10 to the 2x is equal to 2x times the natural log of 10. We can divide each side by the natural log of 10. Now we're almost finished. We have 2x equals the natural log of 52 divided by the natural log of 10. This isn't finished, however. If we multiply each side by 1/2, we can get rid of this 2 and get our answer. In this case, our best answer is the natural log of 52 divided by 2 times the natural log of 10. We can estimate this value, but unless you're asked, the previous answer is the best. So there you go. Those are a few ways that you can solve exponential equations.